Good morning. We are looking at frequently asked questions on homework 2.1 last night, so Unit 2, homework problem number 1. And we're looking at problem number 9 to start with. So problem number 9, you're multiplying these two expressions together, and so 2 and 9, that's 18. I'm then left with x to the 4/3 and x to the 6, and so I have like bases, and so if I have like bases, I can add my exponents. Let me come over here on the side and add these together. We know that when we add fractions, we need a common denominator, so 6 will become 18 over 3. So I get 22 over 3. That's kind of side work there. That means I'll have 18x to the 22/3. I was also asked about number 10, which is a problem where you have a lot of different ways that you can work this problem. So I'm going to start in this first set of parentheses, and let's see here. I have an x squared in the numerator and x cubed in the denominator. So they share two x's, which means I can cancel out two x's, and I'm left with one x in the denominator. This y to the -3 can come to the denominator, and now it'll be y cubed. And z will stay where it is, so I just have a 1 here in the numerator. In my next set of parentheses, again, there's a lot of different ways I can work this problem. I have an x to the -4th in the denominator, so that's going to come to the numerator. I get x to the 6th then. And then the z cubed. I actually won't have anything in the denominator, so I could just put a 1. Now I'm going to take care of this -2 exponent, so I'll have 1 over y cubed z times x times x to the -12th z to the -6, which I know means that both of those go to the denominator. So I'll have 1 over x to the 12th z to the 6th. And now how do you multiply fractions? You multiply the numerators together and the denominators together. So how many x's will I have in that denominator? I'll have 13. I'll have 7 z's, and then I'll have a y cubed. I was asked about number 13. Number 13 is going to be a review problem. So I do know it's arithmetic, and I know that because it gives me a common difference. So make sure you must know it's arithmetic. I know the sum. I do not know how many terms. I do know A1, but I don't know A sub n, so I have two unknowns, which means I need another equation with the same two unknowns. So I'm going to skip a little room. I know that the first term is 21, the nth term is A sub n, and I know the common difference is also 21. So with that, I can set up the explicit formula. So A sub n minus 21 will equal d times n minus 1. And I'm just going to solve for A sub n would equal 21n. So from there, I'm going to plug that in for A sub n. I did have someone ask if they could use their calculator. You probably would not have a calculator from the front section. But this problem you would have a calculator on. So I'm going to multiply by 2 because I don't like dealing with fractions. And I'm going to go ahead and distribute this n. So 21n plus 21n squared. And I believe all of these are divisible by 3. So, and the way I know that, do you guys know your divisibility rule of 3? If you add the digits, 2 plus 1 is 3. 2 plus 1 is 3. 9 plus 7 plus 2 is 18. If when you add the digits, the sum is divisible by 3, it means that number is divisible by 3. And so I'm just actually 21 goes into all those. I just tested that on my calculator. So I can actually divide through by 21. So that actually makes this problem much easier. So I get 462 equals n plus n squared. So this is a quadratic. I'm out of room. Now let's see here. I'm going to come up here. So I'm going to take that quadratic and set it equal to 0. And to solve a quadratic, I can use quadratic formula. So n will equal negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1. Let's go ahead and simplify what's under that radical. So I'm getting 1,849. And then I end up getting n would be negative 1 plus or minus 43 over 2. I know that negative 1 minus 43 cannot be an answer because that would give me a negative n value, and here n is the number of terms. So negative 1 minus 43 would not apply. So I will have negative 1 plus 43 over 2, which would be 42 over 2, which is 21. Question about problem number 14. Let me bring this up so you can see 14. Ooh. There we go. We do know this is arithmetic because it gave us d is 2. Notice here it does tell us that we're working with 12 terms. That's important. That may have been what you missed that meant you couldn't get the problem there. So the sum is 456 of 12 terms. I don't know A1 and I don't know A sub n. So I have two unknowns, which means I need to use substitution. So I know the first term is A1, I know the nth term is A sub n, and I do know the common difference is 4. So I set up the explicit formula, A sub n minus A1 equals 4 times n minus 1, and I need to solve. I need to go back. I know n is 12. And how do I know n is 12? Well, go back and look. It gave you S sub 12. So now I know A sub n will equal A1 plus 12 minus 1 is 11. 11 times 4 is 44. I can now substitute that in. So I know this is A sub 12. So I can now substitute that in for A sub 12. I'm kind of out of room, so I'm going to come down here and sub that in. So I get 456 equals 12 divided by 2 is 6. I don't know A1, and for A sub 12, I have a quantity I can plug in for that. So I'm going to go ahead and divide 456 by 6. A1 plus A1 is 2A1 plus 44, and so I'm going to subtract 44 from both sides, and then divide. So A1 is 16. Someone did ask about 15, about the recursive rule. Remember, recursive does have two parts to it. Recursive is always saying, what are you doing to the previous term to get A sub n? Well, here, what am I doing to the previous term? It looks like I'm subtracting 10. Now, the thing about the recursive is you don't know what you're subtracting 10 from. Are you doing 3 then minus 10? Are you doing 1/2 and then subtracting 10? You have to have more information, and so that information is just simply a term. So you could have said A sub 2 is 15. That would be perfectly fine. And so now you know if you want to find A3, you take 15 and minus 10. You could build the sequence off that. You could have had A sub 1 is 25. That was given to you in that statement. So you have some flexibility there.